Today's lesson is going to focus on working with quadratics. We're going to start with the discriminant and determining the number of real zeros. Also, we're going to try to determine the nature of those zeros, whether they're going to be nice, whether they're going to be radical, whether they're going to be rational. And that's going to help us with our method. We're going to identify x-intercepts, we're going to identify vertex form, and we're to determine whether that vertex is a max or a min. And then we're going to talk about some strategies around appropriate methods here. We know that the quadratic formula, completing the square, and factoring are all legitimate methods in order to find solutions. So we're going to try to talk about which method is going to be most effective depending on what type of a quadratic you get. Here's our first example, and we're going to start with evaluating the discriminant. It's going to be b squared minus 4 times a times c. You can go ahead and use a calculator for this, but this ends up being 400 minus 16, which gives us a value of 384. Worth noting that discriminant is not a perfect square, so we're not going to have really nice answers. And if we're not going to have really nice answers, factoring is probably not our best method. The next thing you want to take a look at is decide between quadratic formula and completing the square. The thing worth noticing here is we've got a leading coefficient that can divide out, and if I divide it out of the 20, I still have an even number of 10. So I'm going to use the method of completing the square here. This is going to give us x squared minus 10x, and we're going to kick the 2 out. And because we are solving for x-intercepts, I'm going to put a 0 over here to help us remember that that's what we're doing. We'll go ahead and complete the square inside here. That's a 25. And because I have added 25 on the inside, I've actually added 50. So I'm going to subtract 50 to offset that. And I now have 0 equals 2x minus 5 quantity squared minus 48. That happens to be vertex form. So in my vertex form spot here, I will write y equals 2 x minus 5 squared minus 48. And I have the vertex form there, and I can identify the vertex as 5, negative 48. And the parabola is right side up here, so that minimum value, or excuse me, that vertex value is a min. Now, we'll go ahead and finish the process of completing the square here and solving for x in order to get our x-intercepts. We'll add 48 to both sides. We'll divide by 2. Half of 48 is 24. We'll square root both sides. I get the square root of 24 equals the absolute value of x minus 5. Do a couple of steps in one here. We get a plus or minus 2 root 6 if we divide out a 4. And I'll add 5 to both sides. So I will have radical form x-intercepts of 5 plus 2 root 6, comma 0, and 5 minus 2 root 6, 0. Those are my two x-intercepts in radical form. You can go ahead and use your calculator then to put those into decimal form. Worth noting on this slide is that we didn't have a perfect square discriminant, so factoring was not going to be our method. We could have used quadratic formula or completing the square. Either one of those methods should have gotten these two zeros. Go on and take a look at the next example. Here we're going to look at y equals negative 2x squared plus 6x plus 20. It asks us to find the discriminant, so we'll go ahead and do that first. We'll do b squared minus 4 times a times c. That is 36 plus 160. If you go ahead and do that in your calculator, that gives us a discriminant value of 196. It is worth noting that 196 is a perfect square. And perfect square discriminants lead us to the possibility of factoring. So I'm going to go ahead and use the method of factoring. Y equals negative 2 x squared minus 3x minus 10. Okay. Another key that factoring might be a good idea is the fact that there was that greatest common factor to take out. We can then write in factored form x minus 5, and x plus 2. Our x-intercepts then are 5, 0, and negative 2, 0. Okay. Asks us for vertex form. We could do, there's a couple of different methods here. We could use that completing the square process in order to get vertex form. The other thing we could do is we could find the middle of the x-intercepts and work that way. So we know that our x-intercepts are 5 and negative 2. To find our line of symmetry, it's going to be halfway between those. So 5 plus negative 2 over 2, that gives us 3 halves, or 1.5, which gives us an x-coordinate of our vertex as 3 halves. We can then take that 3 halves and put it into our original equation, or we could put it into our factored form for the x. So we'll go ahead and do that. Y equals negative 2, 3 halves minus 5, 3 halves plus 2. Got to do a little calculator work here, but you end up with a vertex here of 49 halves, or 24.5. We can then turn that vertex into vertex form of an equation. I'm actually going to write down here because I got a little bit more space. Y equals negative 2 because of the stretch and the flip, x minus 3 halves squared plus 49 halves is my vertex form. And that vertex, because of the negative 2, is a maximum value. Here's our third example. We'll go ahead and start with finding the value of the discriminant. The value of the discriminant is b squared minus 4 times a times c. That is 25 plus 72. We end up with a discriminant value of 97. That is not a perfect square, so we will not factor. With this one, there's not a common factor that can come out with that 3 and the 5, so I'm not going to use completing the square. I'm going to use the quadratic formula here. So we're going to go with x equals negative b plus or minus the square root of 97 all over 6. That's 2 times a. So our x-intercepts then, our radical forms, would be negative 5 plus the square root of 97 all over 6, comma 0. That's one of them. The other one would be negative 5 minus the square root of 97 over 6, comma 0. Those are not particularly nice, but they are x-intercepts, and we could find decimals from there. I'm going to leave that, finding that decimal work to you. The vertex form here is really kind of a tedious process, but it is worth noting that because we use the quadratic formula, that the line of symmetry for this parabola is y equals negative 5 over 6. That comes from that first portion, that first fraction of the quadratic formula. So the x-coordinate of the vertex is negative 5 over 6. The y-coordinate can be found by substituting that value in. I'm not going to do that right now because that's not a skill that you're going to need at this point, but it is worth noting that that vertex value is going to be a minimum value because of the stretch factor of 3, but it's not flipped upside down. So filling in a little bit of information here, there would be a y-coordinate for the vertex that you could find by substituting in. You'll end up with some decimal values, which are not particularly nice, but that process would be pretty consistent. Kind of to wrap up here, to talk about what we did. The first thing we did was we evaluated the discriminant. And if we ended up finding a perfect square discriminant, a reasonable method would be to factor. If we end up with a not perfect square discriminant, we are either going to use completing the square or we are going to use the quadratic formula. And an indicator for completing the square is that if there's a GCF and the b term is still an even number when you're done, completing the square is a pretty reasonable process. But when you get odd b values, completing the square ends up having some fraction or some decimal values, which ends up being probably a little more work than you want. So then quadratic formula would be useful if b is odd. The key to, the other key to noticing, to knowing what to do here is factoring is only going to work when we've got a really nice discriminant. Quadratic formula and completing the square, if done properly, will always work. So keep that in mind as you're working through these. But we want to be able to make some decisions about what our most efficient method is going to be. And that's just a little bit of a tip to help you with that.